All right, so as promised, let's actually go ahead and jump into the formal definition of what these regular expressions are all about. So if you remember before, we had all these cute little regular operations that allowed us to begin combining these things in some cute and clever ways. So if we combine things in cute and clever ways and continually do that over and over and over and over again, we're going to create what are referred to as these regular expressions. So formally, these regular expressions are defined recursively. Basically, the empty set is going to be a regular expression. The set containing the empty set, or the set containing just a singleton thing from the alphabet, those are all going to be regular expressions. And then we're allowed to take those things and combine them with the unions or the or. We're allowed to combine them via concatenation, or we're allowed to apply this star operation. And then you can keep that process going over and over and over again. So you can union and then star and then concatenate and then star again and then union. And you can see where this is all going to begin snowballing just out of control. So anything that can be constructed via this fashion is then going to be referred to as a regular expression. So to put a little bit of context here, I want to look at just a couple nice little examples. So down here, I'm going to have a laundry list of things that are genuinely regular expressions. You can see that some of them have multiple operations to get to them. So you can see that B is going to be a concatenation followed by a star, whereas D is going to be a star and another star followed by a concatenation. So that's where this notion of them being defined recursively comes into play, is that there's lots and lots of little tiny operations that then begin to snowball and create these big, massive lists of regular expressions. So the word or the string I want to play with is then going to be 101010. And all I want to do here is identify if that string lives in these particular regular expressions. So basically a yay or a nay as to if it lives there or if it doesn't live there. So right off the bat, the very first one, which I think is an A, it's really, really tiny, but it is in fact an A, it will live here. So the reason for that, you are not seeing that right away, is that this 0, 1 star is absolutely anything that can be made out of zeros and ones. 101010 is definitely made out of zeros and ones, so it satisfies that rule. So absolutely, it does in fact live in this world. Option B, if you look at it, what it's going to be is it's going to be made out of 0 ones, and you have as many copies of 0 1 as you'd ever want, including none at all. So we have things like the empty. We would have 0 1, 0 1 0 1, or 0 1 0 1 0 1, and we keep on going from there. You can see that all of those entries have to start with a 0, other than the empty string, but this thing is definitely not empty that we're looking with, so it doesn't start with a 0, so we're definitely going to fail in that rule. It exists as like a substring on some of them, but it's not going to exist as one single standalone entry. If I flip them around, well, excuse me, I choked for just a second. If I flip around the 1 and the 0, we should actually work then. So hopefully you can kind of see that as I jumped into that. So if I flip them around, I'm still going to get empty. Now I'm going to get 1 0, 1 0, 1 0, 1 0, 1 0, 1 0, and then so on from there. So definitely 1 0 1 0 1 0 is going to live in that regular expression. Again, there's technically two little operations happening there. There's a concatenation and then followed by a star operation. All right, so what about option 3? So option 3 has 1 star followed by 0 star. So what that means is I can have as many ones as I'd ever want, and then I can have as many zeros as I'd ever want, but I can't have crisscrossings between the ones and the zeros. The ones have to happen first, and then the zeros have to happen. So the answer to that thing is then going to be no. It sometimes is beneficial to begin thinking about what the machine would look like for that particular regular expression. It's also a nice connection to where we're going to be going later in this section. But if I were to try to think about a machine, it would have this ability to spin on 1, and then maybe I'd leave on a 0, and then I'd spin on 0 and have both of those be accepting states. So if I came in with the 1 0 1 0 1 0, I'd spin on 1, advance on 0, and then I'd die. So I'm definitely not going to be in this bin because I have all the ones first, followed by all of the zeros. So we die there. Unfortunate, but oh well. All right, what about part E? So part E, if you look at it, it's going to have a forced 1 initially, followed by as many zeros as you'd ever want. which again, our thing clearly does not fit that pattern. And if it helps to look at the machine, I'm going to have a forced 1 followed by as many zeros as I'd ever want. So I come across on the initial 1, I can spin on my first 0, and then I have another 1, so I die. So definitely fails there. And the last one, so part F, we're definitely failing on that one because I'm coming in with a 1 right away, and that thing requires me to have a 0, and I definitely don't have a 0 as my first term. So 2 of those things are definitely going to be satisfied, which is great and dandy. The other ones, unfortunately, are not going to be satisfied, which is less great and less dandy, but they are what they are. If you are curious, I do have, I guess I have writing out what these entries happen to be, but I do also have the machines that then correspond to what those things happened to look like. So they're kind of a nice little game to begin connecting some of the stuff that we had from before and trying to think about the regular expressions as emerging to machines, because these are all one and the same. So that's where we're all kind of blending these things together. So the bottom 3, we kind of sketched out the machines already. The B and the C, I actually made use of this nice little cheesy epsilon transition. So basically it's 0, 1. And then if you want to, you can go back to the beginning and then start over with another 0, 1, and then go back to the beginning and then start over with the 0, 1. So you can do that as many times as you want. Same thing with the 1, 0. You advance on 1, advance on 0. If you want to go back to the beginning, you can, and then start that process over and over and over again. So it's a nice little check to see how all of those things are going to come into play. So the next video, I'm going to jump into some of our old favorite machines and actually begin writing them up as regular expressions. So that's where we're going to live then, is start with the machine, draw them in regular expressions. Then we're going to take some regular expressions and then try to draw them as machines. And then again, chat about how these two worlds are actually identical and see where we want to go from there.